Try to think back to spiral 1. For a rectangular area, what is the best shape to maximize the area for a given perimeter? What is the best shape to minimize the perimeter for a given area? Do you remember? It's a square. This lesson is about optimizing area and perimeter, and we've already seen this back in spiral 1 when we tried to find the shape that would give the maximum area or the minimum perimeter, and that's where the square came in handy. So we're going to go back to that idea in this lesson. Brenda has 30 patio stones. The total area is 30 meters squared, so each stone is 1 meter squared. What side lengths will minimize the perimeter? She can't cut the patio stones. Okay, so we're looking to minimize the perimeter. So we have to, in our mind, think what's the shape that will minimize the perimeter for a given area? It's a square. So start by drawing a square, and let's just label the sides. I'll use L for length. Now I know that the area is 30 meters squared, so I have to use my area formula for a square to figure out what the length is. So we'll start with my formula. A is equal to length times width. In this case, length and width are the same, so it's length times length, or just length squared. Now I have to substitute the value that I know. I know area is 30 meters squared, so I can put that into my formula. But that equals the length squared. So to find just the length, I have to do the opposite of squaring, which is square root. So I'm going to take the square root of 30. It's about 5.5 meters. However, she can't cut the patio stones. So it doesn't really make sense that we would have 5.5 meters in length. So what do we do with this? We don't have the right answer. We can't have 5.5 meters by 5.5 meters because that would involve cutting the patio stones. So there has to be a way to work around this. So because she can't cut the patio stones, we can't make a square, so we have to go to the next best thing. So instead of 5.5 by 5.5, we're going to make an adjustment to be 5 by 6. So we just went down to 5 meters and went up to 6 meters. 5 times 6 is 30, so we still have an area of 30 meters squared, and this is the shape that is closest to a square as possible. So, to answer the question, what side lengths will minimize the perimeter? 5 meters by 6 meters will minimize the perimeter. Bob is using a 10-meter rope to section off a rectangular area in the corner of a warehouse. What is the maximum area he can enclose? Okay, there's that word maximum area again. So we have to think, what shape are we talking about? A square. Now this question's a little bit different because if you look at this diagram, here I've got the walls making the corner, and this rope is sectioning off that corner. So the rope really only covers 2 sides of the rectangle area. So we don't really know for sure if we're going to be using a square since the rope only covers 2 sides. So we need to do a little investigation. So what we're going to do is set up a table with possible widths and lengths for this rectangular area. Now the rope is only 10 meters, so the width and the length have to add up to 10 meters. So we can have a bunch of different possibilities that do that. We could have 1 meter by 9 meters, that adds up to 10 meters. We could have 2 meters as the width, 8 meters as the length, 3 meters by 7 meters, 4 meters by 6 meters, etc. We can have a lot of possibilities here. But what's the area for the enclosed space for each of those possibilities? Well, area is length times width. So if we look at all the different possible widths with their lengths and what area they make, we find 25 meters squared is the maximum area. So the takeaway message here is if you have a question like this where you're just covering 2 sides of the rectangular area, a square is still the shape that gives you maximum area. Bill is enclosing a 120 square foot shed. So that's an area, just to be clear. What dimensions will minimize the cost of the walls? Okay, now it's talking about minimizing the cost. Why are we talking about cost now? I thought we were talking about perimeter and area. Well, think a little deeper. Minimize the cost of the walls. So if we're looking at a shed, what part of the walls? Well, it's the part around the outside. It's the perimeter. So we're trying to minimize the perimeter. If we have a small perimeter, we're going to have less of a cost for the walls. So this is a minimizing the perimeter question. So we have to think, what's the shape that minimizes the perimeter for a given area? It's a square. So Bill's shed is 120 square feet. This is another way of writing square feet. We know it's going to be a square. So I just labeled the side lengths of the square x. X is just the side length, okay? So we're going to do similar to what we did in the very first example. We're going to start with the formula for the area of a square. In this case, a equals x squared. We know the area, it's 120. So to find x, we need to take the square root. So the square root of 120, it's about 11 feet. Therefore, an 11 foot by 11 foot shed will minimize the perimeter and thus minimize the cost of the walls. But let's say Bill decides to build the shed next to his house instead. The area still must be 120 square feet. So we, again, need to find the dimensions that give the smallest perimeter. So this time, we're not necessarily going to be dealing with a square because the shed's tucked up beside the house. We don't need to build a wall on this side. So we're really only dealing with 3 sides. So because this may not be a square shed, let's do an investigation like we did before. So I'm going to call this part of the shed the width, this part of the shed the length. We know that width times length gives us the area, so we need to choose possible values of width and length that will give us our desired area of 120 square feet. Once we have a list of possible widths and lengths, then we'll go through and calculate what the perimeter would be so that we can answer our question. So let's just start building our list here. Let's say the width is 1 foot. If the width was 1 foot and the area has to be 120 square feet, what would the length have to be? Remember, width times length has to be the area, so 1 times something gives us 120. So what is the length? Well, it's 120. So we have one possibility in our table. Width is 1 foot, length is 120 feet. That gives us an area of 120 square feet. So let's try another possibility. What if the width was 2 feet? What would the length be? Well, 2 times something has to be 120, so that something is 60. So another possibility is a 2 by 60 shed. You can go through the same process. If the width was 3, the length would have to be 40. And you can just keep going and going and going. So eventually you'll have a list, and I stopped at 9, but you could keep going. At a certain point you want to stop though and actually calculate what the perimeter is. So let's go back. If the width was 1 and the length was 120, what would be the perimeter of this 3 sides? Don't forget you have a width here and a width here. So we have to do 1 plus 1 plus 120. So that gives us a perimeter of 122. For the next one, width is 2. Length is 60. Plus another width, that's 64 as the perimeter. So we can keep going through that process, and we end up with this list. Now you'll notice the perimeter decreases, decreases, decreases. It keeps decreasing. Oh, now it goes up again. So if we continued this list, we would notice that the perimeter starts to go up again. So as soon as the perimeter starts to increase again, you know you can stop making a list of possibilities. This is the lowest perimeter right here. So what dimensions give the smallest perimeter? 8 feet by 15 feet gives the smallest perimeter. So the takeaway message from this example is if you're dealing with a situation where you're only covering 3 sides of the rectangle, you're not going to get a square. You have to do a little investigation like I did here to find what the dimensions would be. You can't say it's a square in this case.